So next on the docket is engine emissions devices and sensors that are used by the computer to control fuel delivery and thus reduce emissions and so on. So as you can see, there are a whole heap of wiring underneath the hood of this 09 minivan that I've done a bunch of videos on. So we'll go over a few things to try to help kind of piece it all together. There is really too much to talk about, but this will help give you a better understanding of how the fuel delivery and the ignition timing, which is the spark timing. Remember, we talked about valve timing and ignition timing. Well, ignition timing is the timing of the spark delivery, or in other words, the ignition of the air fuel mixture. Because depending on what the driver of the vehicle wants from the engine, either full throttle or just idling, that is going to change the ignition timing for optimum fuel delivery and emissions and power and so on. So we are looking at the upper plenum, the upper intake plenum, which is right here. So we can see our air enters the engine. There's an air filter right here, which I'll take out and I'll show you. The air that's rushing into the engine travels through this snorkel. It passes by this sensor right here, which is a very important sensor. That is the mass airflow, or the MAF sensor. The mass airflow sensor, through these wires that go to the computer, tell the computer how much air is traveling into the engine. Okay, because the more air means the more fuel. So the computer needs to know that. And it knows that by this sensor here that is plugged into the air intake snorkel as the air passes by it. So the air travels through, it passes by the throttle blade, which is right here, and I'm going to take this off to show you what the throttle body looks like. So when you step on the accelerator pedal, you are actually opening a valve in here that allows more air. More air means more fuel, and so on. The air enters the intake plenum, and depending on what cylinder is on the intake stroke, that air is going to get directed into whatever cylinder it is. You can see our ignition wires right here. This is a 6-cylinder engine. We have 3 ignition wires right here, and the other 3 go back there because it's a V6. And if you can see the writing on these wires, you can see the number 2 right there. This one will say number 4 on it somewhere. So this is cylinder number 2, which goes right there. This is cylinder number 4, and that is cylinder number 6 right there. So that means that 1, 3, and 5. So 1, 2, 3, 4, 5, and 6. These are the spark plug wires, and underneath the spark plug wire boots, those are the wire boots, is the spark plug that is threaded right into the cylinder. Okay, so that means that each cylinder head, which is down in here where the plugs are threaded into, has an exhaust manifold. You can see the exhaust manifold, that shiny tin shield right down there is the exhaust manifold. So there's an exhaust manifold fastened there, one back there, and underneath all of this you can see the exhaust, what we call the crossover. Okay, down there, which carries the exhaust out the tailpipe. Underneath the intake plenum, we have our fuel injectors. The fuel injectors are responsible for spraying the fuel into the cylinder. I don't think we can see it at any point here because of the plenum is in our way. But the fuel, as we probably know, comes from the gas tank via the fuel lines. So here's one fuel line here that if we follow it, it goes all the way to the back. And this is another fuel line. So one of these lines is the main line. And the other fuel line here, which is actually a vent line that holds the fuel vapors. It's the vapor line. Okay, so one of these fuel lines is a main line, which carries the fuel to the engine. And the other line is the vapor line, which we'll get to in a second what the purpose of this line is for. There's my throttle body. Okay, so when you step on your accelerator pedal, you are actually opening up this blade via this electronic, there's a little motor inside here which opens the throttle body, which allows more air to enter the engine. This is the air filter right here, so the air passes through that filter before it passes the mass airflow, which I have unplugged. The mass airflow sensor is inside there. This is a special screen that helps break up the airflow and allows the sensor to properly read the airflow. It meters the airflow going into the engine. There is the exhaust crossover, as I had mentioned earlier, which carries the exhaust gases, and it goes to the back where it meets the rear manifold, exhaust manifold, and from there it goes out the tailpipe. So for the exhaust, we can see the exhaust, the rear exhaust manifold, okay, and right up in there, you can see where the crossover pipe fastens to. Okay, coming from the front, and then the exhaust travels out here, and then it goes through this guy here, which is called the catalytic converter. Some of you probably heard of a catalytic converter. It's a very important emissions device. Basically, catalytic converters are referred to today as three-way catalysts or three-way CATs because they reduce 3 different types of emissions. Carbon monoxide, which is a silent deadly killer we talk about in health and safety. Oxygen, nitrogen oxide, and the third one is hydrocarbons. So those are the 3 gases that are produced when we burn air and fuel in a cylinder, and the responsibility of the catalytic converter is to convert those emissions into mostly carbon dioxide and oxygen. Okay, so it reduces the emissions coming out of the exhaust. That's what we call a catalytic converter. You can see after the catalytic converter, there's a sensor right there that's plugged into it. That is what we refer to as an O2 sensor or an oxygen sensor. So most V6 or most vehicles will have an oxygen sensor before the catalytic, and I can just see mine up there. Okay, that's the pre-cat O2 because it's before the catalytic, and that is the post-cat oxygen sensor. The purpose of the oxygen sensor is exactly what it is named. It senses the amount of oxygen content in the exhaust. Okay, and the computer makes the appropriate adjustments. If there's too much oxygen in the exhaust, it might add some fuel. If there's not enough oxygen in the exhaust stream, it might take away some fuel. Because remember, we have an ideal air-fuel ratio that we want to maintain for a proper burn and so on. And to maintain that air-fuel ratio, we use all these different sensors. So these guys are very important for emissions. The catalytic converter, the oxygen sensor up there, and this oxygen sensor here, and this oxygen sensor basically will monitor the activity of the catalytic converter. If the catalytic converter is inactive and not doing its job, this sensor can detect it, and this sensor will tell the computer, you know what, this catalytic converter isn't doing anything, and it might set a trouble code for a catalytic, which is usually a P0420. P meaning powertrain, and 0420 is usually the code you get for an inefficient catalytic converter, a very expensive component. These can be hundreds of dollars, close to $1,000 in some cases. Very important emissions device. There's the fuel tank there. And this device right here is what we call a charcoal canister. And the charcoal canister is responsible for holding the fuel vapors. Decades and decades ago, we used to just sort of let the fuel vapors emit into the environment, and that is bad. So now we contain the fuel vapors that are created inside the charcoal canister, which we'll get to in a second. So hold on, back to the exhaust. So as you can see, the exhaust stream leaves, it gets filtered in the catalytic converter, the emissions get reduced, and it travels out the tailpipe, past the resonator right here, and out the tailpipe. So the fuel vapors get stored in the canister, And you can see our two fuel lines right here. Okay, so if you remember, I showed you at the top of the engine we had two fuel lines. One of them is the main feed line from the gas tank that carries the fuel to the engine. The other line on this design is the vent line. And the vent line, when the computer commands it, will take the fuel vapors from the canister and burn it in the engine with the air-fuel mixture. So the vapors are stored in the canister, and when the computer determines it wants some of those vapors into the cylinders, it will activate a few sensors, which we'll go over quickly, and it will allow the fuel vapors to travel through this other line. It's hard for me to tell. I think this is the pressure line here with this yellow tag, and I think this is the vent line. Okay, and as you can see, those lines travel, there, and they go up there to the engine. So there are the two lines here that we followed from the tank. The main pressure line, which is this one right here. This line right here. Okay, where it goes into the fuel rail, which is under here, and the fuel rail are what the 6 fuel injectors are attached to. All right, and this is the vent line right here. So the vent line is attached to this guy right here. You can see the electrical connector attached to it, and that's what we call the purge valve. And the purge valve is commanded on by the computer at certain times to allow the fuel vapors into the engine through the intake and through the intake runners and so on. So the purge valve we would consider an output of the computer because it's controlled by the computer, whereas most of these sensors here are inputs to the computer. Okay, we talked about the throttle body already, the electronic throttle body. There is the harness right here. Okay, throttle bodies used to be controlled by a cable, like just sort of like a bike cable that was attached to your gas pedal. Now they are all electronic, like this. Okay, and if we follow all these wires under the hood of this car, if we follow all these wires, they go, okay, this harness right here, all these wires travel through this big harness right here, and they go into the computer. And you can see the harness down in there underneath the overflow jug, and the computer is actually located behind the air box right here. It's located right under here. And that is the computer that does all the work, all the inputs from all the sensors go into the computer. The computer does all the calculations instantaneously to control the fuel delivery. So what happens is, over time, some of these sensors fail. And the computers in these vehicles do a self-test on all these different sensors, and they can determine which ones are working and which ones are not working. And if one fails and the computer picks up on that, it's going to set a trouble code. And that trouble code will also be associated with an engine light. Excuse me. An engine light. And you can see that my engine light right there stays on. So that is telling me I have a problem. One of these sensors or one of these devices is failing. So how do we go about diagnosing what the problem is? Well, there's a couple ways, and what I'm going to show you is sort of old technology. Today's technicians use scopes and laptops and state-of-the-art $5,000, $6,000, $7,000, $8,000, $9,000, $10,000 pieces of equipment to diagnose these vehicles today. So I'm just going to show you a couple older, sort of outdated things, but it will kind of give you an idea of what's going on, hopefully help you with a better understanding. This here is a quick code reader, so it's something you can buy at Canadian Tire. Okay, and at the other end you can see our electrical connector attached to this cable, and on this vehicle, right underneath me here, not sure if you can see, probably can't, there is a connector. And I know where it is on my vehicle because I plugged it in so many times. And I plugged the tool into the connector. And I hope, I don't know if you're going to be able to see because of how bright it is. That's unfortunate. Oh no, that's not going to work. Okay, well anyway, what I do is I cycle through the menu here. And it's reading, and it says at the top there, let's see if I can do this. There we go. It's the best I can do. Let me go back a second here. Okay, so I can go to read codes. I can go to erase codes. I can go to live data. I can go to view freeze frame data. And there's a few other options here, but I'm going to try to kind of keep it simple for you guys. Sorry, I'm a bit challenging holding this code reader at a certain angle that you can see here. So it's loading. I have the key on right now, ignition off. So K-O-I-O, key on. Sorry, K-O-E-O, key on, engine off. That's the term we use to describe the key in the on position, but the engine not running. Key on, engine off. Okay, and I'm going to go through the menu here to see why I have a trouble code. So the first one says read codes, and then I can go down to erase codes, but I don't want to erase codes. So I have to go all the way back up to read codes, and then I'll press enter. And then I will go to stored codes. And let's see what the code is I have stored. So the code I have stored is a P0449, and the description is evaporative emission system vent valve. So it's the EVAP system, which is the system responsible for storing and burning the fuel vapors. Remember I showed you the charcoal canister near the gas tank and the vent line that carries the fuel vapors to the engine, and the purge valve that was bolted to the engine that allows the fuel vapors to get drawn into the intake to get burned in all the cylinders. So with that system is a component called a vent valve, which we didn't locate under the vehicle. I didn't show you, but the vent valve is basically responsible, is also part of that emissions EVAP system. And it just allows the gas tank to vent, because pressure gets built in the tank, in the gas tank, and the pressure has to get vented at certain times. And this vent valve is an output of the computer, and it is responsible for opening and closing when the computer tells it to vent the gas tank. And if the computer detects that the pressure is not able to build in the gas tank, then it might set a trouble code. It might suspect that the vent valve is not doing its job, it's not sealing, and the pressure in the tank is not able to build, and then it might set a code P0449, which is the evaporative emissions system vent valve. So that's why some of you might be familiar with the message that you get on the display on some vehicles. If you have a problem, it says check gas cap, because the gas cap is also responsible for sealing the fuel system. And if the gas cap, if you leave it off after you fill a tank, then the system is not able to build pressure, and the computer will detect that, and instead of sending you to a shop, to spend half your day, it will just put a message there as a reminder, hey, check your gas cap, you may have left it loose, and if you check your gas cap and it's tight, then you have a leak somewhere else, and that leak could very well be the vent valve. Okay, so I have checked my gas cap because of this trouble code that I have stored. I have checked my gas cap. My gas cap is tight. I checked the seal. Everything looks good. So I'm pretty sure I have a vent valve problem. So what we're looking at here is a scan tool, and this scan tool is outdated technology, but it's a good platform for you guys to kind of get started on getting an idea of what we're talking about. These quick code readers that you buy for $50 are great. You keep them in your glove box, and they're great to have lying around. This used to be the go-to technology, but nowadays, as I mentioned, we're using scopes and laptops, and the technology is a lot more advanced than it was 10, 15 years ago when we were using this. So I'm just going to start back at the beginning here. So I plugged this in through the connector down under there where you can't see into my diagnostic port. We are selecting a GM vehicle. Make sure I have my key in the on position and my engine off, KOEO. Okay, it takes me to the next screen. This is a 2009. Okay, so look at 10th digit of the VIN. So when we talk about VINs, that's important to know. The 10th digit of your VIN number gives you the year. So I know the 10th digit of my VIN is a 9, so I know this vehicle is a 2009. It is a Pontiac, and it is considered a truck. Oh, I guess it's not considered a truck. Let's go back. Maybe it's considered a car. Huh. Maybe it's not a 2009. That's interesting. Huh. Maybe it's an 08. Weird. Okay, so I had to go to Chevy Uplander. I could not find Pontiac minivan on this menu. So now I'm under 08 Uplander, Chevy Uplander. I need the 5th digit to confirm it's a U van and not a V. The 5th digit is a U of my vehicle. So we hit enter. It's a base model as far as I'm concerned. We can go through all these different modules here: engine, transmission, ABS, airbag, body control, digital radio receiver. So all these different monitors we can scan through. So I'm just going to take you through the one, but you can see them all. How many different modules are actually incorporated into today's vehicles? Dozens of them. Door locks have modules. Wiper motors use modules, and so on. So we're going to do the engine PCM. It's a 3.9 liter. See, I have two choices here. So the 8th digit of the VIN is going to give me the engine. I got to figure out which one it is. I'm not sure what the difference is between a 3.9 liter I1 and a 3.9 liter W, but mine is a 1. So we'll select that. We're good there. Now you can see all the different options we have using the scan tool here. So we go to diagnostic trouble codes, we go to read codes, current codes. Okay. And there is my code again, P0449. So we would have to look at this vent valve and its circuit to find out why it's setting this code. But we knew that code was there already. So let's go back and look through a few other things here. We can actually go to the data stream right here, which is going to give us a live reading of all the different sensors and so on. So we'll go to engine data. And you can see here all these different sensors that we can actually monitor. So the calculated airflow, barometric pressure, spark, 14 degrees. That's not temperature, that's 14 degrees in relation to ignition timing. Vehicle speed, and we can scroll through. Oop, hold on a second here. We can see at the top here our engine speed, which is our RPM. So that's a good idle right there, about 800 to 850 or so. And we can scroll down through all of this information. Okay, there's our airflow registered by the mass airflow sensor. 6 point something grams per second. Accelerator pedal position. Okay, so if I step on the gas, you can see it's 2% open. 3, the more I step on the gas, you can see my RPMs. You can see my degrees change. And you can also see my spark degrees change in relation to ignition timing. A few other sensors we can monitor: engine oil pressure. Okay. So you can see it climb as I step on my idle or my throttle. You can see my engine oil pressure climb. Okay, there is my evap system. The evap vent solenoid is venting, but we know that's not working. ECT, engine coolant temperature sensor. Right now it's 140 degrees, so we could, if we had a problem with our cooling system, we would monitor this. So as the engine heats up, this number would obviously increase, as you can see it just did right there. Intake air temperature sensor. So this we have a sensor that reads the temperature of the intake air. Injector pulse width. Okay, how long the injectors are pulsed when they spray, when the computer commands them. So you can see how that increases when I step on the throttle. And then we have our fuel trim. Okay, loop status means when the O2 sensors are working, the computer can monitor everything. It can monitor their air fuel going in, and it can monitor the gases going out. So it's a closed loop. And we are commanding a DTC. As we know, I have a code stored. So back to the main menu of the data stream that we can monitor. We can monitor all these different things. If we have a problem, the HO2S, those are the oxygen sensors, the heated oxygen sensor. The fuel trim data, which is the amount of fuel being used, essentially. The evap data, which is the emission, which is the fuel vapors. The system that stores and burns the fuel vapors is the evaporative emissions system. Engine data, okay, cruise and traction data. IPC data, which is the instrument panel cluster. Ignition data. So all these different systems. Misfire data down at the bottom. So if we had a misfire issue with this vehicle, we could monitor all the different components that could be responsible for that misfire. The fuel injectors, the spark, and so on. So we can scroll through all these different things here if we wanted to specify what we were looking at. The cooling in the HVAC, heating, ventilation, air conditioning system. All right. So if we back out of here, and if I want to clear my trouble code, I cleared the code, so let's see if that engine light went out. Still on, so maybe because okay, so let's try it with the key on, engine off. So the code wouldn't clear for some reason, maybe something wrong with the scan tool, I'm not sure. But anyways, I know even if I clear the code, it's just going to come back. Okay, we could go on for hours, but I think that's a good sort of starting point to get you a good understanding of all the systems in place, all the sensors. We talked about a few of them, not all of them, but all the sensors that are in place that the computer monitors for the ideal air-fuel mixture. Okay, some of those are inputs to the computer: the coolant temperature sensor, the mass airflow sensor, the intake air temp sensor, the oxygen sensors. Some of those are outputs from the computer. The purge valve, which is part of the EVAP system. The vent valve, which is part of the EVAP system. There is a fuel tank pressure sensor, which is actually an input, but also part of the EVAP system. We talked about the catalytic converter and its importance and function. And I think that's a good starting point for you guys.